Okay, reviewing the basics, part 3, adding and subtracting integers. Now, it could be that you think you know all about adding and subtracting integers, and that's great because I'm going to touch on some little subtle things that actually are going to help you later in things like physics and chemistry. Okay, so that's fine if you think you know all about it. I'll try and keep this as brief as I can for your sake. Or maybe you don't feel like you really know all about it because you've just memorized some things and how to do these and you want to know a little bit more about it. This lesson covers that too. Or third, maybe you're like, I'm not very good at adding and subtracting integers at all, and I'm going to give you a bunch of weapons to handle adding and subtracting integers. And I hope you can see on my screen, I got lots of weapons coming to handle all sorts of things. So what I'm first going to do is jump in, and I want to talk about positive 5. We're going to talk about integers. We may as well start talking about a positive number, and I'm going to talk about positive 5 to begin with. Positive 5, probably the first time you saw positive 5 was represented on a number line. That is positive 5 right there. It's one way to represent positive 5. And I'm going to show you a second way. There are other ways to talk about positives and negatives, but I'm going to talk about a second way. And these are often called integer tiles, sometimes later called algebra tiles, because you can do algebra with these tiles as well. See that more as we go along. But anyways, integer tiles. The other way to think of positive 5 is not as a spot on the number line. That's sort of a physics thing. You can think of it as a number of objects that are positive, and that's, if you've got science, grade 9 science down already, that's protons. Yeah, so 5 protons. Positive 5 can be thought of as positive, as a 5 protons. Now, let's switch over then. What does negative mean? And so if we wanted to do a negative 2 on the number line, we'd say, okay, negative 2 means instead of going right on the number line, we go left on the number line down to negative 2. And the first introduction you have with this is usually temperature. Usually we talk about, well, you can be above 0 or you can be below 0. Some things can go above and below 0. Some things can't. When you talk about, sort of number of coins you have in your hand, you can't go below 0. I know debt and all that kind of stuff. I'm just saying when you first talk about coins or cookies, you don't really talk about going below 0, but if you start talking about temperature, you can go below 0. That's representing positive and negative as a direction on the number line, and that has huge applications later in physics and algebra and vectors and all those type of things. But the way to represent it with a number of things is, and if you've got the background from science, is to say, okay, negative 2 will be a different kind of object, and I've used just blue objects in here. If you don't have the protons and electrons thing going here, then you can think of it this way, as just 2 blue tiles. Now, if you're trying to draw these on your page, and you don't want to use reds or blues, lots of times what you'll see people do is they'll just draw a little, I'll need a smaller pen there. Let's see how I do with my little pen writing here. So you can draw little positives in these boxes. This presentation, I won't do that. I'll just use reds and blues. But if you're trying to draw them instead of using reds and blues, you can just draw little positive and negatives in there. And that really helps to visualize what each of these means. Finally, if we're going to talk about positive and negatives, we better talk about this number, the one right in the center there, which is 0. It's the dividing number, or it sort of divides this number line into positives and negatives. I don't know, I wanted it to be the same thickness as the other ones there. Okay, so 0. So 0 on the number line, not hard to represent. It's the number right between positives and negatives. There it is. And with algebra tiles, you could put nothing there. And this is where this lesson sort of takes a turn here, is that it is possible to think of 0 as nothing. But the way positives and negatives work is I've got some choices here. I could represent 0 as 1 positive, 1 negative. That's another way to represent 0. And for you science people, that's sort of where we get neutral charge from, is in our bodies and so on, and in any neutral object like a table or your computer or a plant sitting next to you. There's the same number of protons and electrons. So it's not that there's nothing there, it's just that the things there cancel each other out. So then I could go like 2 positives and 2 negatives. It makes it so I've got lots of choices for 0. 0 just means I have the same number of positives as I do negatives. And if you're wondering about the little bunny over here, well, he's going to come up a little later when we start adding and subtracting integers. Okay, that's my introductory page, and now I'm just going to go ahead and do some problems. And if you're trying to figure out how many problems I'm going to do, I think I'm going to do about 7 different problems with adding and subtracting integers and give you some stuff to think about. And the first one's real easy. I'm going to jump right in and go after, with a red, I'm just going to go after and talk about what 3 plus 2 is. And yes, I put a big gap there on purpose because I want to talk about what this means. And so 3 plus 2 on the number line, pretty straightforward stuff, is you start at 3, and then I just want to talk about this bunny here, because this might be how you talked about it in elementary school. And by the way, if you think anything I'm about to do is very, very simple and very elementary, it's not. Hold on. Just stay with me through the examples here, because there's a big idea coming that's going to involve the bunny that will probably blow your brain up a little bit. So just be ready for it. Okay. When we talk about 3, we say, okay, the bunny adding 2 means the bunny's going to go. And I chose this bunny very specifically because he's looking in the right-hand direction there. He wants to go that way, right? So what's he doing? He's going from 3. He's going to take 2 hops this way. There's my little picture of hops there. And then he ends up at positive 5. And that's the way most people first learn the number line and adding integers. So that's a perfectly good way to do adding integers. If the textbook or a quiz or something like that asks you to draw a picture to represent adding integers, you can draw the number line. You're fine with drawing the number line. The other way to do it, which is sometimes better, sometimes not as good, is to just go, well, okay, positive 3 means I have 3 positive tiles here, or 3 protons if you've got that science background available. And to that, I'm adding 2 more. Well, and that's what something I want to talk about here is that when you say adding 2, we really mean we're adding a positive 2. We're adding on positive things there because we're adding. So sometimes we sort of leave out the fact that this 2 here is positive. If it's positive, we don't need to mention it. So really, 3 plus 2 means 3 add positive 2. And that's what I did here. I took 3 and I added positive 2, and I can just count them up. 1, 2, 3, 4, 5, answer 5. Okay? Now, hopefully you're unimpressed by that example. I mean, that goes all the way back to grade 2. I'm setting the foundations for some really big ideas here. Okay, and those really big ideas start right here on this next example. 5 plus negative 2. So I'm going to go 5, and maybe, just be careful here, 5 plus negative 2. And this question, because I know lots about this question, I've taught it for years and years, I know this question is actually easier to think about using tiles. Because I go, okay, positive 5, and then this question asks me to add negative 2. So instead of adding red tiles, add negative 2, I'm going to add blue tiles. And what I know about red and blue tiles are they cancel each other out. In the case of protons and electrons, their charge cancels out. Well, they don't cancel each other out. They don't disappear. I don't want you to think they explode and disappear, even though that's another branch of physics. But anyway, well, let's stay focused here. Protons and electrons, their charge cancels out. And if you're not into the protons, electrons things, what I said before is when you have a positive and a negative, that adds up to 0. And so I like drawing these little 0 circles here to say, oh, that's 0. That's 0. We call those 0 pairs. And if you have 2 0 pairs there, those are all 0. And what I'm left with is positive 3. And that's actually the easiest. No, I don't want that in green there. That's actually the easiest way to do this question. And you might think, no, I can do this on the number line. And I agree with you. If you've done it on the number line many times, it can be pretty straightforward. But there's a little bit of trickiness to this. Can do it on the number line. That is 5 plus negative 2. You got to start at 5. So there's the bunny there. If we're adding negatives, and I'm just going to draw right across the bunny here and say, if it's adding negative, then he wants to go backwards. He's going to hop backwards. Now, remember I said that. You may think this is all really simple, and there's something not simple coming. This example is simple. He's going to jump backwards. And when he jumps backwards 2 times, he gets back to 3, and you get your answer 3. And before I get too far, you've always got your calculator to back you up here. You know, and you go, oh, am I sure about this? And then you can just type in 5 plus, and not this button, not subtract, negative 2. And your calculator knows the answer. It knows it's 3. So you've got that to check these answers out when you're, if you have a brain moment in the middle of a question. Okay, so that's 5 plus negative 2 is 3. Adding a negative with tiles, pretty straightforward. You're just adding positives to negatives and making 0 pairs. Now, 5 plus negative 2 on the number line means the bunny's going to go backwards. And you might have been taught the bunny turns around before he walks. And that's fine. You can think of it that way as well. But stick with my version of it. And if you have another version of it, it'll work the same way. I'm going to say when you have negatives, that means he's going to go backwards. And just remember that for later examples. Okay, next example. Oh, and by the way, what's great about these videos is if you're doing one in the homework with an adding plus a negative, you can always rewind right to this video and just watch this part again and really help yourself to understand that one was a positive plus a negative. Now I'm going to do adding, but instead of adding, I went the wrong way. Instead of adding a positive plus a negative, I'm going to go negative plus a negative. So I start with negative 2, and then I add negative 3, and again I argue. With the tiles, this is really, really easy to represent. That is, negative 2 means 2 negative tiles, or 2 electrons for you science people. And then I'm adding on to that 3 more negative tiles. And what do I get? I just count them up. I've got 2 negative tiles and 3 negative tiles. And the answer is negative 5, because I've got 5 negative tiles. That's really straightforward with the tiles. On the number line, it's a little tricky. On the number line, let's start at negative 2. So I start at negative 2, and then I've got my bunny sitting there, and we're trying to decide which way he's going to go. And we decided that on this last example, we said if we're adding a negative, the bunny's going to try to go backwards. He's just going to go backwards. I'm going to draw this little arrow on him. Say he's going to go this way, backwards for him. And how many times is he going to do it? He's going to go 3 times in the negative direction. 1, 2, 3. And you see I get my answer of negative 5 off the number line the same way I did with the with the tiles. I still think it's easier with the tiles, this particular question. And it just takes experience to know which questions are easier with tiles and which questions are easier with number line. I think, me personally, I think any adding question is way easier with the tiles. Any adding question is way easier with the tiles. Okay, that was negative plus negative. So what I do here, I did positive plus positive, positive plus negative, and negative plus negative. And I'm not going to do a negative plus positive because it's a negative plus a positive just plays out just like this one does. So I'm going to move on to subtraction because that's when things get really interesting. If you're bored and you've fallen asleep in your chair, now's the time to wake up because subtraction is really, really interesting. Okay, so the one I'm going to do, I'm going to jump right in and go after what most people think is a tough one, but the way I've set it up, I think you might find with the tiles, this is an easy one. Negative 4, subtract negative 2. I jumped right into maybe one of the toughest questions of the day. Maybe it's one of the easiest ones. Okay, so with the tiles, negative 4, subtract negative 2. That means start with negative 4 tiles. So these are the negative tiles. I got to have negative 4 of these tiles. And the question says, then take away 2 of the negative tiles. And with tiles, that's really easy to do. You can picture like Cookie Monster. This is just like Sesame Street back when you were a kid. You started with 4 negative tiles, and it says take away 2 of the negative tiles. So I'm just going to take them away. I'm just going to put 9 X's through them and say those 2 negative tiles are gone. And so the answer is just negative 2. This really, really difficult to imagine and explain question is really super easy with the tiles. Now, if you've got an idea of what to do here, if you've got something you've memorized about how to subtract negatives, that's fine. I'm not trying to change that in your brain. I'm just trying to add on to it and give you a little extra knowledge here about why subtracting a negative is like adding. And why subtracting a negative is like adding is because you're literally taking away the negative parts, and that makes things more positive than they were. That really has a lot of science applications. You have negative 4 electrons, and you take away 2 of the electrons. Now you've only got 2 of the electrons. All right, on the number line. Okay, brace yourself for this. This is wild on the number line because it's tough to explain, but I think I can sort of get you there. So negative 4 subtract negative 2 means negative 4, start at negative 4. Now the bunny. Now we said he's going to go backwards here. Yes, that's what it says, is go backwards there. but we also have subtract. So what I'm going to say is subtract means the bunny turns around. Let's just see if he's going to behave here. And let me flip him around here. Oh, he's not going to. So what I'm going to do is flip him right over. The bunny turns around. Yeah, that's what subtracting, that's how I'm going to interpret it. Subtracting to mean is that the bunny flips around and he's not behaving too well there and sitting right where I want him. Got the -4 there. And he's turned around. Now the negative says, then go backwards. So he's turning around and going backwards. So if he's going to turn around and go backwards, that means he's going to go this way. So that works even if you're we're thinking, actually, I learned that negative means turn around, and it doesn't matter. Whichever way you think of this subtract and this negative here, one of them's turn around, and one of them's go backwards, and either way, those two things cancel out, and he ends up going left to right on the number line, ending up at -2. Now, if the bunny part was confusing to you, I agree. Number line is not the greatest way to think of this question. In fact, number line is not usually where -4 minus -2 comes from. When we find out later when questions like this actually happen, when we have to go -4 subtract -2, we're probably talking about an example involving electrons where you have something with negatives that you're taking some more negativity away. That's probably what you're going to be talking about when this kind of question would come up in the real world calculations. You're probably not talking about this situation. You could be, and we'll deal with that. Those kind of discussions are a little more complicated. Okay, if that was sort of confusing, the subtracting and negative, that's okay. I'm going to do another subtracting and negative later. I want to show you a couple other ones just to warm up to get back to that example. So two questions that I think are a little easier, and then come back to one of these difficult ones here. Okay, the next one I want to do is 5 subtract 2. This question is easy on both the number line and with the tiles. If you want to do 5 subtract 2 with tiles, you're saying, okay, start with 5 tiles. This is actually the Cookie Monster question. This is Sesame Street Cookie Monster in this question. They said, okay, teach subtraction to kids. You go, start with 5 of something. And in this case, I'm starting with 5 positive tiles, or 5 protons if you want. And then it says take away 2 of those. And so I'm going to take away 2 of them. I'll do it in green here so you can see the X real good there. And I take away 2 of them. And when I take 2 of those away, you end up with 3. And if you're like, yeah, that's really boring. Well, yeah, okay, I agree that's really boring. But on the number line, I just want to make sure we establish what 5 subtract 2 means, is that if I've got my bunny there on the number line and I'm doing subtract, what we decided was that subtract meant the bunny was going to turn around. And so what I'm going to do is turn this bunny around. So now when we go 2, he's going to go forward. See, for him, forward's this way. He's going to go forward 2 spots and end up at 3. And that's laying the foundation again for understanding subtracting a negative. Subtract, I'm going to take to mean the bunny turns around. And if he turns around and hops the way he wants to go, he's going to go right to left on the number line. Okay, 2 more examples to go. And then you can try some of these out for yourself. And come back and rewatch the parts of the video that you had trouble with. Here's -3 minus 2. And I'm going to do this one from experience. I know this is easier on the number line. I can explain this with tiles, but this particular question is easier on the number line. That is, I start at -3. I get my bunny out, and because I'm subtracting, I took subtracting to mean he was going to turn around, and he turns around, and when he turns around and goes 2, he ends up at -5. This is the type of question people get wrong all the time, -3 minus 2. Don't forget, got your calculator here, -3 minus 2. You can use that to check answers and make sure you're doing things right. Always want you to have your calculator available just to check your thinking out. And okay, let's sidetrack for 1 second. If you're looking at your calculator and go, if I've got my calculator, why do I have to understand any of this? Because later on we'll do this and it won't be -3 minus 2. It might be -3x. Subtract 2x, and when we're doing that, our calculator might not be as much of help, so we better understand what we're doing. Okay, so that's why we're working so hard in grade 9 to understand what we're doing to get ready for tougher math later on. Okay, the tile explanation. Hold on to your hat. This is difficult. -3. So I start with -3. Doesn't start off very hard there. -3. But then it says take away 2, and it means take away 2 red tiles. It says take away 2. It doesn't say take away 2 negative tiles. It says take away 2, which is positive tiles. And there's no positive tiles to take away. And that causes you a big problem when it comes to tiles. And here's the move. Here's the move with tiles that helps you do this question. And I really don't know after all these years whether this move is something you should be doing all the time. I don't know. I really don't know. Because this question actually is pretty reasonable on the number line there. -3 and go left 2 because you're going backwards. Okay, the bunny's turned around. The bunny's turned around, and so you go back 2. So that's not too hard to understand. But with tiles, the way to do this question is to go, okay, well, this isn't a good -3 for this question. The -3 I'm going to use for this question looks like this. I'm going to add in a couple of 0 pairs and use those. Now, take a look at that and make sure you can convince yourself that still is -3. Yeah? Because there's -1, -2, -3, and then zeros. Okay? And with those zeros, now it says take away 2, which I can do now. I can take away 2 of the green ones, 2 of the red ones here. Go with my green pen, that's what I meant to have there. Take away 2 of the positive tiles, and then I get my answer of -5. That's a brain blower, that one. That has huge applications in chemistry and in physics, looking forward to grade 11 and grade 12 in university. So I don't want you to just write this off as just math silliness, because it really isn't math silliness. It really has applications further down the line in science type courses. And some economics, business type things. But it's a little more chemistry science. Okay, well, the nice thing about this being on a video is if any of that was confusing, you can rewind and just listen to it again and get the feel for it and do some of the practice. But as promised, one last example where we deal with subtracting of negatives. Here it comes. This one is the ultimate in integer questions. I'll keep the numbers small and under control. 3 minus -2. Oh, and by the way, in homework it says draw these questions, and some of the numbers that they do when they want you to draw the questions, like 17s and 23s and stuff like that. Okay, here's what I'll say. When you go to do the homework, if it says draw it and the numbers stay below 10, then draw it. If it gets bigger than that, then you don't have to draw the whole thing out. Just do the drawings for the ones that the numbers stay under control. Okay, 3 subtract -2. Let's go after the number line first this time, and then we'll come back to tiles. Both are equally as difficult. This question is the big one in this section. So, 3 minus -2. We start at 3, and we get our bunny out. But subtract says he's going to turn around. So, subtracting, turn around. But subtracting negative, I've also got a negative, says that he's going to go backwards. And backwards for my bunny will be left to right on my number line. So he goes this way 2 times. And what you get is answer +5. Because he turns around, goes backwards, which means he ends up going left to right. That is weird. Yeah? And then so some people memorize it, and maybe you had an elementary teacher that taught you to think, okay, 3 minus a negative, you actually make these both positive, and your 3 plus 2. Subtracting a negative is just like adding. And I have no problem with those rules. I really don't. I just want to explain why those rules exist, that they're just not some random thing we made up. There's reasons why things play out like that. Okay, so hang in for one more example here. I tried to keep the video brief so that you wouldn't get overly bored going through these examples. But 3 minus -2 with tiles. Start with +3. Then this says take away 2 negatives, and there's no negatives to take away. Let me just let you think about that. And maybe you even want to pause the video to really think through the situation. This says from +3, take away 2 blue tiles, take away 2 electrons, and there's no blue tiles to take away. So what are we going to do here to make it so that I can take away 2 electrons, or take away 2 blue tiles? And the answer is use a different 3. This is one version of 3 I could use, or I could use this version of 3. Now convince yourself this is still worth 3. I got 1, 2, 3. That's a 0, and that's a 0, which all seems like a waste of time until you go, okay, now this version of 3 that I have, I'm ready now to take away 2 of the negatives. Here I go, take away 2 of the negatives. And what am I left with? Positive 5, which is the answer to this question. But don't forget, you've got a friend to bail you out. 3 minus negative 2, 5. So definitely practice that in your calculator too, so you can definitely check those answers. All right. I hope I opened your eyes a little bit about integers and that there's a little more than meets the eye than just memorizing rules. We want you to understand this stuff in 9 academic math. We want you to understand how these things work because we know how important it is later in 10 academic and 11U and 12U and chemistry and physics, all these courses, that really understanding what's going on with those is so important. I encourage you to dive into that homework and really try, really engage with trying to understand. I promise you a little bit of effort here will pay off. And any of these examples that seem really confusing, they'll start to pay off and you go, oh, I get that now. And then you'll have that weapon available for all your math and science courses later, that you'll really understand the fundamentals of integers here. Okay, so dive into that homework for that section, reviewing the basics part 3. And other than that, have a great day, and we'll see you in reviewing the basics